do the packet, all that's been videoed. So you can work through and consult the video. I'm just gonna do the same problems, but just new versions of them. Okay? So if I do it today, it's on the exam. All right? So not all of this. The exam is 2 pages, front and back, like a regular test. My handwriting, a problem written out, and answer blank. A problem, just like all of our tests have been. It's 1 class period, so there's hardly, there aren't that many questions on it. Okay? So, I'm just going to run through some random problems that will definitely be on the exam. So here's the first one. Let's find the tangent of 210 degrees.
This one, should I put it in?
No, bring them up here. So what do we do? What do we do? First, we're going to find the tangent of 210 degrees. Delaney? I draw a picture of 210 degrees. Remembering that that's my setup. So 210 will be down here, past 180. Then I make a triangle. And then I figure out that angle right there. Now remember, this whole thing was 210. So what does that have to be right there? Come on, use your common sense.
30.
That's 180.
30 degrees.
This is 210. So what's that got to be? 30 degrees. There's no math. It's not tricky. Just common sense. That's got to be 30. Now, if you look up here on your sheet, there's a handy dandy little 30, 60, 90 sitting right there. So you're going to label the sides of the triangle. And the only thing you have to remember is some negatives. What's negative in that picture?
3, 2, 1, and
The 2 is never negative. The hypotenuse is never negative. Hear me? Okay. Now, I need the tangent. So hopefully you know, but if you don't, oh wow, it's written right here on the sheet. Tangent is opposite over adjacent. So that's going to be -1 over -√3, which is 1 over √3, √3 over 3 is the answer. Okay? Easy, easy, easy. All right, I'm picking problems that are exactly like what's on your exam. So, log base x of 25 equals 2. This is a no calculator problem. So is that one. So we loop-de-loo. So it's going to be x squared equals 25, so x equals 5. Okay? If you know what you're doing, this is going to be so easy. Okay, how about this one? 9 to the 4x minus 2 equals 27 to the 3x plus 1. There are problems on the review that are just like these. I'm just making up new versions for you to practice. Okay? Now, no calculator. What's your strategy? This is not a calculator problem.
4x minus 2 equals 3x plus 1.
Well, I'm going to do something similar to that, but I can't set these two equal to each other right now, because why? These don't match. So you got to make them match. So can you turn them into something? What can you turn them into? 3's. Because 9 is 3 squared, and 27 is 3 cubed. Right? Now, on the review sheet I'm looking at, it's not a 9 and 27, it's a 4 and an 8. But wouldn't you do the same thing with a 4 and an 8? You would just turn them into 2's. Right? Now, well, first of all, what do I do with these exponents right here? That's a multiply. So I'm going to distribute 3 to the 8x minus 4 equals 3 to the 9x plus 3. Now I can set them equal to each other. See the difference? Yeah, you got it. You got to do that. And then you just solve like a regular equation. So it looks like x is going to be -7. just solve like regular. Now, a problem that looks very, very similar to that is something like this. 4 to the x equals 11. Now, if that number had been a 16, life would be perfect, right? But it's not. So, what do we do with a problem like this? This is a calculator problem. This will be on the calculator part of the test. Remember, if I'm doing it today, it's on the exam. Okay? So, what is happening here? What am I going to do? Take the logarithm of both sides. And the minute you take the logarithm, this comes out in front. So x log 4 equals log 11. And since I'm solving for x, I'm going to divide by log 4. Divide both sides by log 4. Right, guys? And there's going to be whatever that is on my calculator. Make sure if you have an old calculator like mine, when you type log 11, you got to close the parentheses before you hit divided by. Some of the newer ones, they don't have that issue, but the old ones do. Okay, let's see what else we got. Oh, let's look at this. There are 2 calculator problems, and for sure one of them at least is going to be on the exam. Oh wait, I need new numbers. I'm just counting them straight off the sheet. I need new ones. So you have a problem that looks like this: 10, 12, 18, and then you got one that looks like this with 17, 13, and 42 degrees. Okay. And the directions say find the area. Find the area of these triangles. All right? And it's calculator, so we're going to use our calculator. And we have our reference sheet, and on the reference sheet up there, close to the top, I see 2 things that say area equals.
Can you do log on this side?
For this problem, I could do the log cosines to find that side, but I'm not looking for a side, I'm looking for area. So I'm going to focus my attention on the 2 up there that say area. This is the one with the big radical. This is Hero's formula. You need it. So first we need the perimeter, which is 40. And then we're going to do the semi-perimeter, which is half of that, or 20. And then in the formula, that's S. So 20, and then 20 minus 18, 20 minus 12, and 20 minus 10. Remember, I am not teaching you anything today. I'm jogging your memory. All this is in your notes. This happens to be 5.5 and 5.6. You can go back to your notes and look up anything you need. I'm jogging your memory. Okay, so I type all that in and hit square root. Don't forget to square root it. And the answer is, for that one, is 56.57. If I did it right. Now, this is another area problem. It's a triangle and I want the area. But I can't do it this way because why? I don't have enough sides. Because this depends on knowing the perimeter. If you know the perimeter, this is the way to go. But if you don't know the perimeter, you can't. So what does our other formula say? 1/2 side times sine of included angle. Somebody said this morning, Miss Ford, that's not what it says. It's got all those letters. Listen, that's a formula. I can't make the letters match every problem. You have to understand how the formula works. 1/2 side times sine of included angle. Type it in. So that one is 73.94. I know I'm the teacher, and of course it's different for the teacher, but these are not hard problems. You need to familiarize yourself, or I should say, re-familiarize yourself with how we find them, how we solve them. Right, now, Avery, this is another calculator problem. And shoot, I keep doing this. I'm sorry, guys, I gotta change these numbers. I keep copying it off the paper and I wanna give you different examples. Sorry about that. It says find C.
Oh, this is,
So if we're gonna find C, now C is not area. So even though that problem looks an awful lot like this one, we're not doing the same thing. We're not finding area, we're finding C. C is a side. Law of sines or law of cosines. Now remember how you decide. If you can do this and have both, it's the law of sines. Do I have both on any of my? Nope. So it's not going to be law of sines, it's going to be law of cosines. Which, by the way, is second from the top up there. That's the law of cosines. So again, I'm not expecting you to memorize it, although you should have it memorized. But you need to know how to use it. The law of cosines says C squared equals 24 squared plus 18 squared minus 2 times 24 times 18 times cosine 47. Okay, now, type it all in. One of the places where we see a lot of mistakes is, you get this all typed in, and then what do you have to remember to do? Yes, square root. So you get it all, it's easy to type in. You can just type that in, but then you have to remember to square root it. So the answer is actually 17.63. Did somebody not get that? I heard somebody say something. I think that's right. Okay. That was a calculator. These were all calculator problems, for sure. All right, now we're going to do a couple more no calculator problems. So let's say we've got matrix A and matrix B. And we are going to subtract them. Let's do 2A minus B. All right, you know what to do.
Do you multiply all of A by 2?
Everything in A is going to get times by 2. It's like a distributive. So that's going to be 6, negative 2, 10, and 14. And then we're going to subtract B. And to do that, we do entry by entry. So 6 minus 5, negative 2 minus 1, 10 minus 7, and 14 minus 0. Easy enough? Now we also need to be able to multiply these two matrices together. So we need to multiply 3, negative 1, 5, and 7 times 5, 1, 7, 0. So the dimensions of this one, 2 by 2, rows, 2 columns here. These match. Remember, that's the rule for multiplication. The answer is going to be another 2 by 2. So basically, you are looking for these 4 numbers. You're going to multiply these together and get those 4 numbers. Okay, how do we get that number right there? We take this row times this column. So 3, -1 times 5, 7. Multiply each pair, match them up. First and first, second and second, match them up, multiply and add. So that is 8. This one is also in the first row, but now I'm going to use the second column. So that is a 3. Then I'm moving to the second row. So I'm using 5, 7. Oh, times 5, 7. And that 5, 7 times 1, 0. So that one looks like a big number.
74.
74. And this one, you need to be able to do that without a calculator. You can, it's easy. All right. Now we're gonna have an equation, let's say -3 cosine 5x. And you could be asked to find the period, the amplitude, or both. Question might just say, what's the period of that thing? Now, the amplitude of it is 3. Amplitude is the height. So if we were drawing, actually, it's upside down. If we were drawing this, which you're not being asked to graphic, but if you were, it would have that shape. And this would be -3, and this would be +3. That's the amplitude, 3. Amplitude is height. Okay? So how high is the hill? That's amplitude. Now,
72.
the period is 72.
Sure.
How did you know that?
Divide by 5, 360.
So the period is supposed to be 360. Remember this whole 90, 180, 270 thing, guys?
Yep.
But when you put a coefficient in front, it divides all those. Now, some of you get confused. It's always division. Now, if that happens to be a fraction, then you end up multiplying by the reciprocal. But it always starts out as a division. So, this is the period where it ends. 360 divided by 5 is 72 degrees. Exactly right. Impressive. All right. Let's suppose that I have a busload of kids. And there are, let's just say, 60 kids on the bus. Very full bus. 60 kids on the bus. And everybody on the bus likes something, okay? So there's nobody gonna be out here. Everybody on the bus likes something. And here's what we're liking. We're either gonna like math, or we're gonna like English. Okay? So I say to the 60 kids on the bus, okay, everybody's gonna vote. How many of you like math? And of course, like 47 hands go up. All right? And then I say, okay, now how many of you like English? 31 hands go up. Now the question is, how many like only English? All right, now I made this up. I hope it works out. Here we go. We're going to find out. So, what's the problem here? There's too many kids that voted. 78 kids voted. So some of them are like me and they love both. How many? Well, if 78 votes came out of 60 people,
18 in the middle.
then there must be 18 there in the middle. And if the math ball holds 47 people, but 18 of them are already counted, then there must be 29 of them here. And the English ball holds 31 people, so there must be 30 or 13 of them here. So what's the question? How many like only English? 13. Right? Remember, if I'm doing it today, it's on the exam. All right, next, how about this? What if we had to find the third term of 2x minus y to the sixth? Alright, so there's lots of things going through your mind. What's the first thing that's probably going through your mind? Pascal's triangle. And we're gonna have to take it down to the sixth row. Is Pascal's triangle on that sheet?
No, ma'am.
Okay, you better be able to build it then.
Oh, yeah.
You wanna get this problem right, you better be able to build it. And I'm not gonna have you build it down 20 rows or something crazy, but this time we are going to the sixth row, which is right there. So if you're not sure, practice building it yourself. Look back at your notes, Google it, something, get it figured out. Because we need those numbers. Now, if it said expand, we would write down all of these numbers.
Plug in the
It goes clear across the board, and we would do all these terms. Luckily, we don't want to do that. We want the third term, which is right there. So we're going to start with 15, and next to him, I'm going to put a 2x and a negative y. That is a multiplication. And I'm basically done except for my powers. I don't have my exponents on there yet. So I'm thinking, if I were doing the whole problem, my power on x, right here, my power on x would be 6. Here it's 5, here it's 4. So my power on x is 4, which means my power on y is 2, because they gotta add up to 6. Okay, there's no math involved, I count it.
You do 3 and 3.
Now.
Why does that have to be 4
6, 5, 4, Jude. Okay, now, I'm all done except simplifying. So I have 15, 2 to the 4th is 16, negative 1 squared is 1. That's all multiplied. So what's 15 times 16? 240. So my answer is 240 x to the 4th y squared. Remember, there are problems just like this on both review sheets. I'm doing an extra one. They're on the review sheets, you have the answers, plus the videos are loading right now. All right. Let's suppose I walk into class, and there are supposed to be, I think like 22 of you, okay? And I'm gonna give away a book, a marker, and a pen. How many ways can I do that? 22p3. Now, why is it p? Order matters, right? You want to be this, well, I don't know what you want to be, but it's different, right? Whether you get the marker or the book, it's all different. So 22 kids, I'm picking 3, and order matters. Okay? Now, let's suppose I walk into that room with 22 kids, and I don't know, I never counted, but let's say, I don't know, let's say 13 are boys and 9 are girls. I'm making that up. But I decide of this group, these kids, I want to have a committee with 3 of each. So 3 boys and 3 girls. I want a committee of 3 boys and 3 girls. How many ways can I do that? Well, I put all my girls in a pile over there. There's 9 of them. And I gotta pick how many? 3. Does order matter? It's a committee. Committee.
Oh, no.
9C3. If I said I was picking my president and vice president, then it would matter. But not if it's a group, I would choose that 3 of them. And
Times 13,
I have to pick 3 boys. Now, I don't remember if you've ever seen a problem with boys and girls like this, but you sure have seen it with hearts and clubs. Or aces and something, right? Same exact idea. You've got 2 groups, and you're picking a few out of this group and a few out of this group. Now, what if I had a 5-card hand, and I want the probability of no more than 1 king. Now this is a probability question, which automatically means you're going to have a top and a bottom, a fraction. What's gonna go in the bottom?
52C5.
52C5. Now, what's gonna go on the top? Now read it. I need no more than 1 king. Declan?
4C48 for the rest of the other 4, and then a 1C4 for the 4 kings.
Other way around.
Or-
So, what I'm trying to get you to understand here is that no more than 1 king
Okay.
means I could get 1 king, or I could get no kings. Would you agree with me? So what Declan just gave me was 1 king. He said there's 4 kings, just like boys and girls. There's 4 kings in the deck. Oh, I split the cat. There's 4 kings in the deck, and you want 1 of them. How many are in the other group? The non-kings. 48. And you want a 5-card hand, so we must want 4 of those. Notice that's multiplied because you're picking a king and 4 other cards. Or, and Sandra Bridges was making fun of me this morning because I emphasized that word, but I emphasize it because it means add. What am I adding? No kings. Well, no kings would be 4C0 and multiply 48C5. Because no kings would be 5 non-kings. Now, when you type this in on your calculator, and I'm not going to take the time to do it, but when you type it in, if you set it up like this, you got to type all the top in and hit equals, and then divide it by. Don't forget, you can't just hit divided by, because it won't let you divide that part. So you need to hit equals and then divide it by. Okay, here's another one. Obviously, these last few have been calculator problems. Here's another calculator problem. I I don't know, Jackson played for, how long is the lacrosse match? I don't know.
48 minutes.
The whole thing is only 48 minutes?
4 12-minute quarters.
Why does it take so long? Alright, well, I don't know, I'm gonna ignore that fact because it's not gonna fit my problem, but let's say Jackson plays 5 minutes in the first game of the season, and then he plays 9 minutes in the next game, and then he plays 13 minutes in the next game, and so on. Do you see what's happening? Okay, so here's the question. He plays, make sure you understand what these numbers represent. He plays 5 minutes in game 1, 9 minutes in game 2, 13 minutes in game 3, and so on. The question is, how many minutes will he have played in a 21 game season? Alright, so what does that mean? What do I need to do?
Add up all 21
I need to add them all up, right? Only I need to add them all up way past those 3, right? I gotta go all the way out here to the 21st game. A sub 21 means 21st term. Alright, so I'm adding them all up. What kind of sequence is this?
Arithmetic.
And you've got your formulas right here in the middle of the page.
5 plus
Your
4.
arithmetic formulas are these two. And in fact, I'm gonna use that one right there because that's the sum formula, and isn't that what you told me I had to do? So I'm summing up 21 games, so N is 21. What does this stand for?
First digit.
First game, which is 5. Oh no, what does that stand for?
The 21st.
That's the 21st game. Do I know what that is? Could I figure it out? I probably could, but I only have so much time, so I really don't want to. Instead, I'm gonna rely on my other arithmetic formula,
5 plus 4.
which says 5 plus the common difference, which is 4 times 20. So he's gonna play 85 minutes in that game, and we know now that's not possible, but just for purposes of the problem, he's gonna play 85 minutes in that game. And that's the number that goes in right here. So what I'm trying to get you to remember is, sometimes the formula you know you need to add. But sometimes you don't have everything you need. So then you gotta drop back and use a formula that you don't necessarily need in this problem, but you need it to get the number to put into this one. So, I put in 85 there. Looks like my answer is 945 minutes. If I typed it in correctly. Alright, see what else we've got here. Remember, I'm not doing everything today, but I am doing problems that I can 100% guarantee you are on the exam. So, here's some limits. Gotta know how to do limits. Alright, there's a couple of them.
0.
That one is 0. Why is that one 0? That number is less than 1, right? So that is 0. And this one is 6. Right, we got that. We got that. Alright, how about this?
No.
Now, when we did these before, and we actually did them in chapter 2 and chapter 7, so that was probably on your first semester exam too, because it was way back in chapter 2. When we did it in those chapters, you had to draw a picture of that and list a whole bunch of information. On the exam, it's not going to say all that. It's going to say what are the vertical asymptotes? Or what are the horizontal asymptotes? What is the horizontal asymptote? What is the x-intercept? What is the y-intercept? What is the whole? Now, you're not gonna do every single one of those on the exam, but you don't know which one you're gonna do, so we just gotta talk about all of them. But that will be one question on the exam. Okay, so how do we begin? You won't be graphing it on the exam. You can graph it for your own purposes, but your graph won't be graded. So what do we do first? People, we've done this twice this
Don't you
year.
factor them first?
Yes,
Yeah.
you factor first.
Dude.
You factor it. So how does the top factor?
X. Oh, no, it's X minus minus 6 X minus 4, X minus 3.
Oh, I was thinking a different one. Oh, no, I did that wrong, sorry.
Yes, you
Two.
did. Yeah, you did. It's x minus 4, x
Hey, I got
minus
our
3.
brains thinking though, and they
Yes,
said factor,
your brains
so,
are-
yeah.
All right, now what about the bottom? Well, the first thing you want to do on the bottom is take out that 2, but don't lose it. It stays as part of the problem. And then how does x squared minus 9 factor?
X plus 3.
X plus 3, x minus 3. And then we notice that we can get rid of that, which means this problem is going to have a hole. Now, on the review sheet, one of the review problems does not have a hole. Nothing cancels. If nothing cancels, then there isn't a hole. I mean, that's just it. Here we do, and our hole is going to be a point, 3, because that's what canceled out. 3 comma what? Well, negative 1, 12. Plug in 3. So, negative 1, 12. That's your whole. Now, for all the rest of the questions, this is what you look at. Do not look back at the original problem. This problem has one vertical asymptote, and it is at x equals negative 3. Because where do vertical asymptotes come from? The denominator cannot be 0. So x cannot be negative 3. Right? Now, again, I am not teaching you this today. You are going to star this and go back and look it up. Right? Horizontal asymptote, that is the limit. What do I have? I have 1x on the top and 2 x's on the bottom. So my horizontal asymptote is 1/2. X-intercept is whatever makes the thing equal 0. Well, the only number that's going to make this equal 0 is 4. X-intercepts come from the numerator. What makes the numerator 0? And then your y-intercept is what happens if you plug in 0. So if I plug in 0, I have negative 4 over 2 times 3, which looks like negative 2/3. Now again, you're not going to find all that. You'll find 1 or 2 of those things. All right, then there are a couple of problems over the recent material. So how about if I gave you this equation? And said find the center and the radius.
Put the 3 in.
So you better have this in your brain, because we just
Oh, I
did
haven't
this.
dialed in. I
So
can
x
do it on the.
squared minus
I wanna
8x,
do it
y squared plus 12y,
Did you do it, Plus?
and then that
3 plus 1.
comes
Plus,
over
plus.
to the other
on
side.
plus plane.
Yep,
Job 2.
and now we fill in our blanks. So what goes here? 16. Half of 8. Some people missed this yesterday. half of 8 squared, 16. What goes here? And those two numbers get added on the other side also. This guy right here is something squared, x minus 4. This guy right here is something else squared, y plus 6. And all that adds up to something. 55, I think.
Yeah.
Oh, yeah.
So if the question said find the center is
4
4 negative 6. If the problem says find the radius is
Square root of 55.
square root of 55. All right. Another recent question might be, consider this equation. Find the slope of the asymptotes. So again, like I was talking about earlier, yesterday I gave you an equation like this, and you had to find, center, vertices, foci, asymptotes, transverse axis. You had to find all this stuff. On the exam, I'm going to give you an equation, just pick one of those things. So this time I said, what's the slope of the asymptotes? Well, anybody have a thought on that?
4 over 3.
I heard 4 over 3 and 3 over 4.
4 over
That's 3.
Which is it?
4 over 3 goes up 4 over 3.
Plus or minus 4/3. Remember, asymptotes positive and negative. Now, again, if it helps you to draw a picture, go ahead and draw a picture. But I want you to think about drawing the box. Now put your center somewhere. And then, what does that tell you? It's under Y.
Up and
That's telling you you're gonna go up and down 4. And then this guy under X tells you you're gonna go sideways 3. So when you build the box, you're building your asymptotes. Up 4 over 3. That's the slope of your asymptotes. Now, same one, we'll do one more of these. Suppose I said, what are the vertices of this? What are the vertices? Now, here, I know it would help me to draw a picture. You don't have to draw a picture. You can figure it out, you're all good. But I'm gonna go ahead and draw a picture. I have a center at -1, 5. And we already decided that we're gonna count up 4, 1, 2, 3, 4, 1, 2, 3, 4. And sideways 3, 1, 2, 3, 1, 2, 3, right? And that's how I would build my box. Whoops. And here would be my asymptotes. Now, what is the hyperbola gonna look like? Up and down. So this point right here and this point right here are my vertices. Those are the points I want. So I started here and counted up 4, so that would be -1, 9, and -1, 1. All right, so it's that kind of stuff. Let me see what I have missed. We got that one.
Okay, Alex.
All right, I deliberately skipped this one because I thought it was so easy, but 5x minus y equals 6, and 4x plus 2y equals 2. All right, so what? If you're me, you're going to eliminate. Somebody else might say I'm going to substitute, but I'm going to eliminate it. So what that point is, that's how you solve this. Either substitute or eliminate, whatever you like. So I'm going to multiply the top by 2. So 10x minus 2y equals 12. and 4x plus 2y equals 2. So 14x equals 14,
X equals 1.
x equals 1, but I'm not done.
Plug her
Because
in.
now I gotta plug it back in, and keep in mind that is x. I'll do it here. So 4 plus 2y equals 2, plugging in x. So 2y equals negative 2, and y is negative 1. Right? And then I think there's just one more. I think then I will have done them all. Suppose we have something that looks like this. Sine squared, tangent, cotangent squared, cosecant, cosine. What do I do with this?
Turn them into the.
Fraction.
Turn them all into fractions. Now, if it's a sine, I just put it over 1 to keep everything, I'm gonna try and keep everything lined up here. So that's a cosine, so it's just over 1. Now, what's tangent? Sine over cosine. What's cotangent? Cosine squared, because it's squared, over sine squared. What's cosecant?
1
1
over
over
sine.
sine. And once I get them all changed, then I just multiply. So, or cancel. So what cancels? That and that. Sine and that. That with, oh, wait.
Wait.
So what's left?
Cosine squared.
Just him? So the answer is just cosine squared. Okay? So, I don't think I see you people on Monday, do I?
You're last.